Well, good morning or good afternoon, students. I'm going to go over with you how to get started on doing these half-life of radioactive isotopes problems. And this is in your packet. So let me zoom out here. Recommend a pencil because you make mistakes and stuff. It's always good in the balancing problems. So to begin with, let's read the whole problem on these. Okay, so the question is, how much of a 100-gram sample of gold, 198, is going to be left after 8.10 days if its half-life is 2.7 days? Okay, so there's some stuff in there. What we know is, okay, we know how much we start with. We know what its half-life is. We know the ending day. What we're looking for is how much is left after the end of the day. So we know how long it's happened. This is what we're looking, how much is left. So what I always recommend is I start it with the diagram. I'm going to use a square. You can use a different shape if you like. But let's say we have a block of gold, 198, AU 198. And let's say now we got 100 grams of this. I'm going to put 100 grams of gold 198. And I'm going to darken this to represent it's all gold. 198. It's going to break down. It's going to probably lose a neutron or two, probably changing into gold 197, 196, which is a little stabler. Gold 197 is the most common isotope. So draw an arrow to represent the half-life. So here's after the first half-life, how much of this 100 grams will be left? Okay, so, or in other words, what's half of the original 100 grams? And hopefully you're saying, well, we'll have half of it left, which means of the 100 grams of gold 198, then after the first half-life, and let's see, this is the half-life is 2.7 days. So I'm going to go, let's get that labeled in. 2.7 days, we'll have 50 grams left of gold 198. The rest of it is probably turned into gold 197. So we're not done. We need to keep doing this until we get to 8.10 days. So we're going to do another half-life, another 2.7 days. And how much will remain of this 50 grams after another half-life has gone by? So in other words, what's half of 50? Well, it's going to be 25 grams. So after two half-lives have expired, the 100 grams of gold 198, there's only 25 grams of gold 198 left. Now we're just under 6 days. We need to do one more half-life because I'm pretty sure when you add up 2.7 plus 2.7 plus 2.7, it comes out to 8.1. So at this diagram, we don't need to draw any more half-lives because let me in fact I'll do that in a moment here. So my question first is, after this last half-life here, how much of this 25 grams is left? Well, I kind of gave it away there. But yeah, 12.5 grams, so we'll darken that, half of this. So we'll end up with 12.5 grams. So that happens to be what we're looking for, how much is left of gold 198. Now, in these problems, though, what I would like you to do is let's put what the whole elapsed time was, 8.1 days. The whole elapsed time in this particular problem was that many days. We had 100 grams. Half of it broke down after just under 3 days into 50 grams. And another 2.7 days, we only had 25 grams left. And then after another 2.7 days, we were left with only 12.5 grams. Now, in some of these other problems coming up, you're going to be given, say, we'll give you, well, I'll just kind of get you set up with those. So, okay, make sure we've answered the question. 12.5 grams of gold, 198. Now, in number 2, I'll just give you a few hints. In this one, we're looking for the half-life. In the previous problem, we knew the half-life. This is what we're looking for. Oh, and that's what I wanted to mention. In this particular problem, if we take the total elapsed time, if the problem gives you that, if you divide this number, the total elapsed time, by how many half-lives occurred, you're going to get what the individual half-life is. So we got 8.18 divided by 3 of these half-life arrows. That comes out to 2.7. So in the next one, we're looking for what the half-life is. So we're going to start just like we did over here. I recommend start with labeling this like we did here with 50 grams. In this problem, it says it decays to 12.5. So you're going to start here with 50, and you're going to do as many of these half-life arrows and subsequent squares until you get to 12.5. But in this particular problem, it's telling you, they're giving you what the total time is from when you started to wherever you end is 14.4 seconds. So I'm not going to tell you how many of these little half-life arrows we're going to put in, but once you get the proper number of the squares put in, however many arrows we have here, how many half-life generations occurred, just divide it by, take this number and divide it by those, and that'll tell you the half-life. Just like doing 8.18 divided by 3 gives us 2.7. This problem here, we're given the half-life. Okay, so we know for our arrows that the half-life is 12.4 hours. I'm sure we're going to have at least 2 of them, 12.4, oh, better put hours. How much of a 750 gram sample? Okay, well, that's going to be 750 over here, then you'll work over there. And now you're going to have to keep doing this until you get to 62 hours. So you need to keep doing these arrows until all of these arrows add up to 62 hours. So you can figure out that. Number 4, you've got this sample. This is technetium 99. What is the half-life? Okay, so what we're trying to do is you're trying to figure out what's going to be the value on that arrow. We're starting over there with 500 grams of TC99, and it decays to this many grams in this many years. Oh, I'm sorry, my mistake. Yeah, that's what we're looking for. What is the half-life? So you, let's see. So you need to do as many of these arrows to 50, keep doing this until you end up with 62.5 over here at the end. It's probably going to be 4 or 5 or 6 of these little squares you're going to have to draw. And at that point, we know that the total elapsed time is 639,000 years. However many arrows you end up having, you take this number, divide it by the number of those arrows, and then that will be what your half-life is. I like question 5 because you got to work backwards. The half-life, they tell us what the half-life is. If there are 25 grams of the sample left after this many years, so this is the total elapsed time, so I'm just going to go ahead and draw this in. Total elapsed time is 2.8 times 10 to the 10 years. And actually, you can just ignore the times 10 to the 10 in this problem. Just focus on the 2.8s. It tells us there is this much left. So our very last square, we have 25 grams of thorium-232. So just work it backwards. Okay, so we after that, how much would there have been if this was 25 here before that half-life? How much here? And then how much over here? You keep working it back until you get to the proper number of years. Fill this in. We know this is 1.4 times 10 to the 10 years. Again, on this one, you can just kind of cross those off. So how many of these 1.4s do you need to put in until you equal the 2.8? Fill in the material, and then you'll be able to tell us how many grams were in the original sample when you started. So there you go. Let's see. This one I think is just like the start. How many grams were in the original sample? Okay, so we have 5 grams left. So this one's going to be similar here. You start at the end. We've got 5 grams of material left. So just kind of work it backwards, as many of these squares as you need. Let's see. We know the total time is 40.35 days. Okay, the half-life is 8.07 days. So let's see how many grams were left. So just work on this. So if we have 5 grams here, we know we had to have 10 grams here. So just keep working these until all of your arrows, you add up those 8.07s that you get 40 days. So there you go. Bye.